In this presentation, we are going to discuss Worksheet B, number C, part 2. It says to translate the hypothesis claim 2 to symbolic form and complete the pair. The hypothesis or claim number 2 says that the average dispersion or difference between the heights is less than 20 centimeters. So bear in mind, this is a response to the research question number 2, which is not about the population mean. It's not asking about the population mean. That is research question number 1. Research question number 2 is asking about the average dispersion. Not the average, not the population average, but the average dispersion, the average difference between the heights. And as you can see in part C1, we discuss the descriptive measures for dispersion. As you can see, measures of dispersion allow us to analyze the differences between the data values, not the average of the values themselves, but how different they are from each other. Difference, they are related, means to subtract. When we were calculating the mean, we did not have to subtract. We just add all the values and divide by the number of values. But if you're finding how one value is different from each other, you're comparing the values, you're finding the difference, you have to subtract. So the simplest way of measuring the difference between the values is a form of, as a measure of dispersion. A descriptive measure of dispersion is a range, the difference between the highest value and the lowest value. Another descriptive measure of dispersion is the interquartile range, the upper quartile minus the lower quartile, and you can appreciate the negative sign, allowing us to subtract or find a difference. And you've got a more rigorous descriptive measure, the variance. There are 2 formulas to calculate the variance. All the values vary from each other. As you can see, the subtraction sign is there. Method number 1 and method number 2. And then you've got the standard deviation, which is the square root of the variance. This is also explained in weekly notes number 4. Right? Bear in mind, I'm trying to clarify the difference between averages and measures of dispersion. Here it is in weekly notes number 4. There are 3 subcategories of descriptive measures. This is explained in the prior video. Okay, you have the mean, median, and mode, central tendencies, but you've got measures of dispersion, measures of variability or spread, how different the values are from each other. So you have the range, the interquartile range, the variance, and the standard deviation. And you have measures of correlation, which we'll talk about later. But now for C, part 1, well, C, in fact, is about analyzing the differences between the values. Now, we need to do the translation because we did see part 1 already. The translation requires translating words to symbols. This translation of words to symbols, this image there, was explained in a prior video. So let's just focus on what we are dealing with right now. The symbol for population variance is sigma squared. The symbol for population standard deviation is sigma. Sigma is the letter that serves the same function as S, is a symbol that represents in Greek. The English S is used for sample standard deviation. The population, the sigma, the Greek S is used for population standard deviation, which is sigma. So this is the symbol we've got to use to translate the word population standard deviation to a symbol. Now, as you can see, claim number 2 says the average dispersion. When you say average dispersion, you are referring technically to a measure of dispersion, and the one that we have calculated that is more rigorous to use is the standard deviation. Okay, so basically we can replace the word average dispersion or average difference with the word standard deviation, population standard deviation. And I purposefully did not just write the word population standard deviation from the beginning, because I said to myself, I will use that opportunity to explain what standard deviation describes. It describes the average dispersion between the value. Okay. The mean describes an average. The median describes the central number right in the center itself. Okay. The lower quartile describes the value that occupies the 25th percentile, 25%, and so forth. The range describes the difference between the heights and the value. The population standard deviation, as well as the sample standard deviation, describes the average dispersion. Now, whenever a claim is made, it is about the population standard deviation or the population mean. It's about the population. That's what happens in the claim. And data have to be collected from a sample to try to prove or disprove that claim. So this is the statement that we have to translate. It is a hypothesis. And since it's using the less than symbol, it will have to be an alternative because the null carries the equal sign. So the symbol for alternative hypothesis, as we know, is H sub A. So we go to insert equations, H sub A, colon. Now the symbol for population standard deviation, we said, is the Greek form of S. It's called sigma. You have uppercase sigma for sum, that's to add, and lowercase sigma for population standard deviation. Here it is. And by now you all can appreciate why I put the Greek alphabet, because of all these Greek letters appearing to facilitate the translation of words to symbols. So the population standard deviation is less than 20. This is the symbolic translation of the claim. Now, part 2 says, continues by saying to complete the pair. Remember, two persons are debating. One is called the null, one is called the alternative. So we have just outlined the null, the alternative, sorry, the null comes on top of the alternative, and the null always carries the equal sign. And remember, we said in a previous video, you can actually include the inequality sign for the null, but it must be opposite to the alternative symbol. So we're going to delete A, put O. You can put an equal sign if you want. You can just put an equal sign. Or which is the one I normally prefer. You could put The inequality sign with the null, but it have to be in the opposite direction to the alternative for there to be a debate. If it is in the same direction, there's no debate, there's an agreement. So the null could be written that way to complete the pair. Here it is, greater than or equal to 20. So while the alternative is saying, oh, well, the average dispersion, the population standard deviation is less than 20, the null will say, you sure it's less than 20? I think it's equal to 20. But better yet is saying, no, I think it's more than or equal to 20. So here's the translation and the completion of the pair.